Imagine this. You're sitting on your couch, cozy in your morning routine, about to stir a spoonful of powdered milk into your coffee. It dissolves instantly, creamy, smooth, effortless. But have you ever wondered how that delicious creamy powder actually gets made? It started days ago as raw milk inside a cow on a farm. Since then, it's traveled through miles of pipework, been spun in high-speed machines, heated, evaporated, and sprayed into a mist so fine it turned into dust, all without ever being touched by a single human hand. This is the story of powdered milk and the incredible science and machinery that turns fresh dairy into something shelf-stable, long-lasting, and ready for your cup. But before we start, I'd like to ask you for a huge favor. We are putting our hearts into our videos, so please, if you like our behind-the-scenes food discoveries, hit that subscribe button, comment, and share with friends. That would mean the world to us. Thanks for your support, and now let's take a look behind the scenes of powdered milk. Milk collection and testing. It all begins at sunrise on a dairy farm. Dozens, sometimes hundreds of cows are milked twice a day using automated milking machines. These machines gently draw milk from the cows and pipe it into a large stainless steel tank where it's kept cool at around 4 degrees Celsius to preserve freshness. From here, a carefully scheduled system of milk tankers comes into play. Each tanker is essentially a mobile refrigeration unit, insulated, stainless steel, and designed to keep milk cold and uncontaminated during transport. These trucks often collect milk from multiple farms before heading to the factory. But before that milk can be used for powder, it has to prove it's worthy. At the entrance of the milk processing facility, a sample is taken from every batch before unloading. In a quality control lab just steps away, technicians immediately begin testing. They're checking temperature, butterfat content, protein levels, pH, and, most importantly, microbial safety. If the milk shows any signs of spoilage or contamination, it's rejected on the spot. But when it passes, it's green-lit for transformation. Now it's pumped into giant refrigerated holding tanks inside the factory. And from this point on, the clock is ticking. Every step must be done quickly and cleanly to preserve quality. Because what started as raw, fresh milk is about to become something entirely new. Pasteurization. Now that the milk has passed its tests, it enters the heart of the factory, the processing line. The first major step? Pasteurization, a process that's been keeping milk safe for over a century. The milk flows through a closed system of stainless steel pipes into a piece of equipment called a plate heat exchanger. Inside, metal plates transfer heat rapidly, bringing the milk up to 72 degrees Celsius, or about 161 Fahrenheit, in a matter of seconds. This isn't boiling, it's just hot enough to kill harmful bacteria like E. coli, Listeria, and Salmonella, while still preserving the milk's natural flavor and nutrients. But the clock is tight. After just 15 seconds, the milk is immediately cooled back down to below 5 degrees Celsius to prevent any spoilage or nutrient breakdown. This entire process happens in a sealed system. No air, no light, and no chance for contamination. It's precision-controlled and monitored by digital sensors that track every degree, every second. And the milk never stops moving. Once pasteurized, it flows directly to the next stage. Still fresh, still cold, but now clean, safe, and ready for transformation. From here on out, it's not just milk anymore. It's a food ingredient with a global future. Separation and standardization. At this point, the milk is safe and clean, but it still doesn't quite match the blueprint needed for powdered milk. Enter the process of separation. The milk is pumped into a high-speed machine called a centrifugal cream separator. It spins at thousands of revolutions per minute, enough force to separate the milk into two components: cream, which is rich in fat, and skim milk, which has almost none. This happens in a continuous flow. No churning, no waiting, just smooth mechanical precision. Now, why separate the milk? Because not all powdered milk is the same. If the factory is making skim milk powder, most or all of the cream stays out. But if they're producing whole milk powder, a calculated amount of cream is blended back in, carefully measured to match exact fat content specifications, usually around 26%. This step is known as standardization, and it ensures that every batch of powdered milk, whether for babies, bakeries, or emergency rations, has the same nutritional profile and consistency every single time. Digital controls monitor the fat-to-protein ratio in real time. It's dairy chemistry in motion. Once the milk is standardized, either as whole or skim, it's stored briefly in large, chilled tanks, waiting for its next transformation. Next up, the water begins to disappear. Evaporation. Now that the milk has been perfectly balanced, it's time to start removing the water. Because regular milk is about 87% water, and powdered milk is almost none. That means nearly all the liquid has to go. This begins with a process called evaporation. The milk flows into a towering machine called a vacuum evaporator. Inside, heat and low pressure work together to gently coax out the water without boiling the milk. Under vacuum, water can evaporate at much lower temperatures, around 55 to 65 degrees Celsius, helping preserve flavor, color, and nutrients. It's like boiling, but in slow motion and under complete control. As the milk moves through multiple stages of the evaporator, steam rises off and is collected. Meanwhile, the milk becomes thicker and thicker, turning into a rich, creamy concentrate, almost like condensed milk. By the end of this step, nearly half the water has been removed. Why not take out all the moisture here? Because doing it all by evaporation would take too long, use too much energy, and risk overheating the milk. That's where the next step comes in. A rapid, high-tech solution to finish the job. Spray drying. But before we get to that, let's pause and appreciate what's just happened. In just a few minutes, this once liquid milk has already lost much of its water and gained the perfect texture to enter the most dramatic part of the process. Spray drying. Now comes the most critical and fascinating step, turning that thick, creamy milk concentrate into fine, dry powder. It all happens in a massive piece of equipment called a spray dryer, often a steel tower several stories tall. At the top of this tower, the milk concentrate is forced through high-pressure nozzles or spinning atomizers. These devices break the liquid into a fine mist, thousands of tiny droplets suspended in midair. Then comes the heat. Inside the drying chamber, hot air, up to 200 degrees Celsius, 392 degrees Fahrenheit, is pumped in. But thanks to the small size of each droplet, the heat only needs a few seconds to evaporate the remaining moisture. The result? As the droplets fall through the chamber, they shrink and solidify into tiny particles of dry milk powder. By the time they reach the bottom of the tower, the transformation is complete. Milk has become dust. But this isn't just any dust. Each grain is uniform in shape, size, and moisture content, a result of finely tuned airflow, temperature control, and fluid dynamics. It's powdered engineering at its best. The newly formed powder is collected using cyclone separators, swirling chambers that capture the powder from the air and send it to the next stage. And just like that, the milk has become shelf-stable, storable, and ready to feed the world. But before it's packed, it still needs to cool down and be polished. Let's head to the next step, cooling and sieving. Cooling and sieving. After its rapid transformation inside the spray dryer, the powdered milk is still warm and slightly fragile. Before it can be packed or stored, it needs to cool down. The freshly dried powder travels through gentle conveyors into a cooling system, usually a fluidized bed, where cool, filtered air flows up through the powder, lifting and gently tumbling it. This not only brings the temperature down quickly, but also prevents the particles from clumping or sticking together. Once cooled, the powder moves on to a vibrating sieve, a kind of mechanical filter that shakes the powder through fine mesh screens. This step removes any oversized chunks, foreign particles, or inconsistencies, leaving behind only smooth, free-flowing milk powder. And depending on the end use, a small amount of anti-caking agent, usually a food-grade mineral like tricalcium phosphate, might be added at this stage. It keeps the powder from clumping during storage, especially in humid conditions. The result? A fine, uniform, ivory-colored powder that pours like dry sand and dissolves instantly in water. clean, dry, and flawless. This is what the world will know as powdered milk. But there's still one final step before it can hit the shelves. Packaging. Let's keep going. Packaging. Now that the powdered milk is cool, clean, and perfectly consistent, it's ready for the final stage, packaging. This step is all about protection, from moisture, oxygen, and time itself. The powder flows directly into automated packaging machines, which fill it into a variety of containers depending on where it's headed. Retail tins or pouches for grocery stores, bulk sacks for bakeries and food manufacturers, or sealed drums for export or humanitarian aid. But before sealing, there's one last detail, and it's an invisible one. Each package is flushed with nitrogen gas. Why? To push out oxygen, which can cause oxidation and reduce shelf life. Nitrogen acts as a natural preservative, keeping the powder fresh for months, or even years without refrigeration. Then the package is sealed airtight, labeled, and sent through metal detectors and weight checks to ensure safety and accuracy. From here, it's boxed, palletized, and shipped to grocery stores, remote communities, military rations, or even space programs. What started as fresh milk on a farm just days ago is now a dry, nutritious, and shelf-stable product that can travel across continents. All thanks to a carefully controlled journey of science, heat, and precision. And that's the journey of powdered milk, from the udder of a cow to the inside of an airtight packet. It's easy to overlook something so ordinary, but behind each spoonful lies a world of engineering, microbiology, and industrial precision. In just a few days, fresh milk is tested, pasteurized, concentrated, dried, cooled, and packaged, transformed into a lightweight powder that can feed millions where refrigeration or fresh supply is hard to find. So next time you stir some into your coffee or pour it into a recipe, remember, you're not just using milk. You're holding the result of a remarkable process designed to make nutrition travel farther, last longer, and feed more people. Thanks for watching. And if you enjoyed this behind-the-scenes journey, don't forget to like, subscribe, and let us know what factory-made food you'd like to see next.
Hey there, food lovers! Have you ever wondered how your favorite bagel gets made? From the moment the wheat is harvested in the fields to the delicious golden brown bagel that you grab on your morning run, it's an impressive journey of science, tradition, and of course, great taste. If you're new here, make sure to hit that subscribe button and turn on notifications so you never miss an exciting culinary journey. To truly appreciate the bagel, we need to go back centuries. The story of the bagel begins in Eastern Europe, specifically in Poland, during the 17th century. It's believed that the bagel was first created as a tribute to the King of Poland, Jan III Sobieski, after his victory over the Ottoman Turks in 1683. The shape of the bagel, a perfect ring, was said to symbolize the stirrup of a horse, a nod to the king's military prowess. As Jewish communities spread throughout Europe, so did the bagel. It became a staple in Jewish bakeries across the continent. But it wasn't until the early 1900s that the bagel made its way to America, brought over by Jewish immigrants who settled in New York City. In the 1920s, bagels became a street food sensation in the city's Lower East Side. But how do factories today make such consistent, delicious bagels on such a large scale? Everything starts with the wheat. The flour that forms the base of every great bagel begins in the field. Farmers harvest specific strains of wheat that are high in protein and gluten, two key components needed for that classic bagel chewiness. Once harvested, the wheat is cleaned and ground into flour at the mill. This process is more detailed than it sounds. The wheat is carefully sorted to remove any debris, then milled into fine flour that is ideal for bagels. It's important to get the protein content just right, as this affects the dough's structure and elasticity. Then, the flour is transported to the bagel factory, where the real magic is happening. In a bagel factory, dough is created in massive mixers designed to handle large batches. First, flour is poured into the mixer. Flour is the foundation, but it's not the only ingredient. To make the dough, factories add a precise mix of water, yeast, salt, and sweeteners like barley malt syrup. This combination ensures the dough rises well and gives the bagel its subtle sweetness and perfect consistency. After adding the ingredients, the mixer begins to work its magic. The dough is mixed for around 10 to 12 minutes at high speeds, kneading the ingredients into a smooth and elastic dough. This is crucial because bagels need a dense but supple dough. Too soft and they'll be airy. Too tough and they'll be too hard. Once the dough reaches the right consistency, it's time to let it rest. Resting helps the gluten relax and the dough to become easier to handle during the next steps. At this point, the dough is still quite large, and the factory needs to divide it into smaller pieces. Factories use automated dough dividers to ensure that each portion is exactly the same size, usually around 3 to 4 ounces for a standard-sized bagel. The next step is crucial: the shaping of the dough into a perfect round shape. In traditional bagel making, bagels are hand-rolled, but in a factory, this process is done using automated machines. Now, here's a step that sets bagels apart from most other bread products: the boiling process. After the dough is shaped, it's time to give it the signature dense, chewy texture that makes bagels so unique. Bagels are boiled briefly in water before baking. In most factories, the water is heated to just under boiling temperature, typically around 205 to 210 degrees Fahrenheit, 96 to 99 degrees Celsius. Sometimes, a small amount of baking soda is added to the water to help the bagels develop that golden brown, glossy crust when baked. The boiling process causes the bagels to puff up, creating the chewy exterior and slightly soft interior that we all know and love. Once they're done boiling, the bagels are carefully lifted out of the water and drained before they head to the next stage. Next up, baking. The boiled bagels are now ready to go into the oven. But not just any oven, a special type of oven known as a conveyor belt oven. This system allows for continuous production, with bagels traveling through the oven on a belt for a consistent, evenly baked result. Bagels are baked at high temperatures, usually between 450 and 475 degrees Fahrenheit, 232 to 246 degrees Celsius, for about 10 to 12 minutes. As they bake, they undergo a magical transformation. The outside becomes crispy and golden, while the inside remains soft and chewy. The conveyor belt moves at just the right pace to ensure every bagel gets the perfect amount of heat. And, unlike regular bread, bagels retain their moisture and thickness due to that critical boiling step. When they come out of the oven, these bagels are perfectly baked with that signature glossy golden brown crust. Some bagels are left plain, but many bagels are topped with delicious additions, whether it's sesame seeds, poppy seeds, everything seasoning, or other flavorings. At this point, bagels are either manually or automatically topped with seeds, onions, or other flavorings. This step is crucial because it's not just about taste, it's about creating the visual appeal that makes each bagel so recognizable. Some bagels also receive a light glaze of sugar syrup to add a subtle shine and sweetness to the crust. Once the bagels are fully baked, topped, and glazed, it's time to prepare them for packaging. Bagels are carefully arranged in packaging trays or bags. Depending on the factory, bagels may be packaged by hand or with automated machines. Some factories also offer pre-sliced bagels for customer convenience. After packaging, the bagels are sealed tightly to preserve their freshness. Some factories even use nitrogen to flush out the oxygen in the packaging, which helps extend shelf life without the need for preservatives. Once packaged, the bagels are ready for distribution. They are loaded onto pallets, shipped out, and sent to stores and bakeries, ready to be enjoyed by bagel lovers everywhere. And there you have it. From the fields where the best wheat is harvested, to the dough mixing, and finally the packaging, this is how bagels are made in a factory. While the process may seem automated, it's important to remember that every bagel is crafted with care to deliver that perfect combination of texture, flavor, and freshness. Whether you like them toasted with cream cheese or piled high with smoked salmon and onions, every bagel begins with these simple yet crucial steps. So the next time you grab a bagel, you'll have a deeper appreciation for the artistry and precision that goes into making these delicious treats. Thanks for joining us today at Factor Review, And if you enjoyed this behind-the-scenes look at bagel making, don't forget to like, subscribe, and hit the bell for more fascinating food production videos. Did you know that mango trees can live for over 300 years and grow up to 100 feet tall? That's right, these giants of the fruit world are more than just delicious snacks. They're living pieces of history, producing fruit for generations. But how do farmers manage these massive trees and turn their fruit into the perfect mangoes you find in your local supermarket? Let's take you inside the world of modern mango production. The mango's path from seed to supermarket starts in an environment that's more laboratory than farm. What if I told you that the first few months of a mango tree's life are spent in conditions as carefully controlled as a spaceship? It's true. The journey of these delicious fruits begins in high-tech greenhouses, where every aspect of their early growth is meticulously managed. In these controlled environments, mango seedlings are nurtured under optimal conditions. Temperature, humidity, and light are precisely regulated to ensure the best possible start for these future fruit bearers. This isn't your backyard gardening. It's agricultural science at its finest. But why go to all this trouble? Well, mango trees are a long-term investment. It takes years before they start producing fruit. So farmers need to make sure they're starting with the healthiest, most robust trees possible. That's where grafting comes in. Grafting is a technique that's been revolutionizing mango production. It involves joining a scion, that's the part with the desired fruit characteristics, with the rootstock. This process allows farmers to create trees that combine the best traits of different varieties. You get the fruit quality of one type with the disease resistance or growth habits of another. It's like creating a superhero mango tree. The grafting process is precise and requires skilled hands. Technicians carefully join the two plant parts, ensuring they grow together successfully. This method is crucial for producing quality mangoes efficiently, as it allows farmers to replicate the characteristics of the best performing trees. As the seedlings grow in the greenhouse, they're constantly monitored. Only the healthiest plants make the cut for transplanting to the orchard. This careful selection process is another way technology is improving mango production. By starting with the best possible trees, farmers can increase their chances of a successful harvest years down the line. When it's time to move the young trees to the orchard, it's not as simple as digging a hole and planting. The transition from greenhouse to open field is a delicate process. The seedlings need to be acclimated to outdoor conditions gradually. This involves slowly exposing them to varying temperatures, wind, and sunlight to toughen them up for life in the orchard. The choice of orchard location is crucial too. Mango trees thrive in well-drained soils, so the best orchards are often situated on slopes. This natural drainage helps prevent excess moisture around the roots, which can lead to disease. Climate considerations are also key. Mangoes are tropical fruits, so they need warm temperatures and plenty of sunlight. They also need protection from the extreme heat and cold. Farmers use data on local weather patterns to choose the best spots for their orchards, ensuring the trees will have the right conditions to thrive. While weather plays a crucial role, it's not the only factor in mango cultivation. Ever wondered how farmers know exactly where their trees are thirsty? The answer involves a surprising blend of nature and cutting-edge technology that's changing the face of mango production. In the world of mango farming, precision is key, and that's where microchip technology comes into play. These tiny devices, smaller than a grain of rice, are revolutionizing the way farmers manage their orchards. They're at the heart of advanced drip irrigation systems, transforming water management into mango production. These microchip-equipped systems are like high-tech detectives, constantly monitoring soil moisture levels. They provide real-time data to farmers, allowing them to know exactly when and how much water their trees need. This precision is especially crucial in sandy soils, which are notoriously challenging for moisture retention. By delivering water directly to the roots in carefully controlled amounts, these systems drastically improve irrigation efficiency. They're not just saving water, they're optimizing growth conditions for the mango trees. It's like giving each tree its own personal water butler, ensuring it gets exactly what it needs, when it needs it. But water management is just one piece of the puzzle. When it comes to pollination, mango farmers in Southern California have found an unlikely ally: flies. Yes, you read that right. Green bottle flies and blowflies naturally assist in pollinating mango blossoms. This natural approach eliminates the need for additional pollination resources, making the process more efficient and environmentally friendly. However, growing the perfect mango isn't just about water and pollination. Protecting the fruit from environmental stressors is equally important. One innovative technique involves using paper bags to shield mangoes from excessive heat and sunburn. Farmers choose between brown or white bags depending on the mango cultivar, ensuring each variety gets the protection it needs. This simple yet effective method helps maintain fruit quality throughout the growing season. But it's not just the fruit that needs protection. Mango sap can cause skin irritation similar to poison ivy, making harvesting a potentially hazardous task. To address this, workers wear protective clothing, including long sleeves and gloves. This not only safeguards the workers but also prevents sap burn on the fruit, which can occur if mangoes aren't handled correctly during harvesting. The combination of advanced irrigation technology, natural pollination methods, and protective measures for both fruit and workers represents a holistic approach to sustainable mango farming. It's a perfect blend of nature and technology, working together to produce high-quality mangoes while conserving resources and protecting the environment. This use of precision agriculture in mango farming reflects a significant advancement in agricultural technology. It's not just about producing more mangoes, it's about producing better mangoes more efficiently. These innovations are helping farmers overcome the challenges of mango cultivation, from long maturation periods to alternate bearing patterns. Yet, for all the high-tech solutions in mango farming, the final step relies on something surprisingly low-tech: the human touch. In fact, the way a mango is harvested can make or break its journey to your fruit bowl. What's the secret behind getting that perfect juicy mango to your local supermarket? It all comes down to timing and technique. Mango harvesting is a delicate process that requires skill and precision. Workers carefully assess each fruit's ripeness, looking for subtle changes in color and firmness. The perfect mango should be firm, yet give slightly when gently squeezed. But here's the tricky part. Mangoes are climacteric fruits, meaning they continue to ripen after being picked. This characteristic is crucial for managing harvest timing to ensure optimal flavor upon reaching consumers. When it's time to pick, workers don't just yank the fruit off the tree. They use a gentle tugging motion. If the stem snaps off easily, it's a sign the mango is ready. But there's more to it than just pulling. Harvesters leave a 4-inch stem on each fruit. This isn't just for looks. It prevents sap from oozing out and causing damage, a problem known as sap burn. Once picked, the mangoes aren't just tossed into a bin. They're carefully placed stem down in trays. This positioning allows any remaining sap to drain without touching the fruit. It's a simple step that makes a big difference in maintaining quality. But the journey from tree to table is far from over. After harvesting, mangoes enter a high-tech world of post-harvest processing. This is where science and technology take center stage to ensure you get the best possible fruit. First up is grading. Mangoes are sorted based on size, weight, and appearance. This isn't just about making them look pretty on store shelves. It's a crucial step for ensuring quality and marketability. In the US, mangoes are graded into categories like US Fancy, US Number 1, and US Number 2. To make the cut for US Fancy, a mango needs to be clean, mature, and free from defects. It's like a beauty pageant for fruit, but with much higher stakes. After grading, it's time for storage and transportation. This is where temperature control becomes critical. For mature green mangoes, the optimal storage temperature is 55 degrees Fahrenheit, while ripe mangoes should be kept at 50 degrees Fahrenheit. These precise temperatures help maintain quality and extend shelf life. Now, here's where things get interesting for California-grown mangoes. Unlike their imported counterparts, these local fruits don't undergo hot water treatment. This treatment is typically used to prevent fruit flies in imported mangoes. The result? California mangoes often boast superior flavor and freshness. The California mango harvest runs from mid-July to September, depending on the variety. These locally grown fruits are often hand-picked at peak ripeness, ensuring better flavor. You'll often find them at farmers markets, where their superior taste sets them apart from imported varieties. All these steps, from careful harvesting to precise grading and storage, come together to ensure that the mango you pick up at the store is at its flavorful best. It's a blend of age-old farming wisdom, and cutting-edge technology, all focused on delivering the perfect mango experience. As we've seen, mango production is being transformed by technology at every stage. From microchip-equipped irrigation systems to controlled atmosphere storage, these advancements are improving fruit quality, sustainability, and efficiency. The National Mango Board's investment in research is driving further innovations, enhancing production and post-harvest practices. The future of mango farming lies in blending traditional methods with cutting-edge technology. Genetic research is focused on developing more resilient varieties that can withstand climate change and market fluctuations. As consumers become more interested in the journey of their food, technology is enabling greater transparency, allowing us to trace mangoes from farm to table. The next time you bite into a juicy mango, consider the complex blend of nature and technology that brought it to your plate. It's not just a fruit, it's a testament to the evolving world of agriculture, where innovation continues to shape how we produce our food.